Okay guys, so in 17 we're just trying to prove what type of quadrilateral PQRS is exactly. So I've gone ahead and I've plotted those 4 points and connected them. What I would do first is we'll start kind of basic. We'll prove that it's a parallelogram first, and what I'll do is I'll just find the slopes of all 4 sides. Because they're already graphed for us, you can just count. So to go from P to Q, we're going up 1, 2, over 1, 2, 3, 4. So PQ, side PQ, has a slope of, what did I say, 1, 2, 1, 2, 3, 4. So rise 2, run 4, which is the equivalent to 1/2. I'll go ahead and find the side that's opposite PQ, which is SR. So for me to get from S to R, I go up 2 over 1, 2, 3, 4. So for SR, it's the same thing. So we've just proved that we have one pair of opposite sides that are parallel. We're going to do the same thing for PS and QR. So for this side, I'm going to go up 1, 2, back 1, 2, 3, 4. So for PS, it was up 2, back 4, which just makes this a negative slope. So this slope is going to be negative 1 over 2. And then over here for QR, up 2, back 1, 2, 3, 4. Again, negative 1/2 slope. So we've just proven that this is a parallelogram, at least, because you have both pairs of opposite sides are parallel. Well, to kind of determine if it's something more than that, we could think it's not going to be a rectangle, because here you guys don't have slopes that are opposite reciprocals. You have slopes that are opposite, but they are not reciprocals of each other. So we don't have any right angles on this quadrilateral, which would rule out a rectangle and square. But we could see if this is a rhombus by determining if all 4 of those sides are congruent, because that is a property of a rhombus. So we will, we can kind of draw those little right triangles to find the distance of what each of those sides are. Or you guys could use the distance formula 4 different times using all of those sides. But because I've already got it graphed on here, I'm just going to kind of draw my little right triangle here to figure out the length of PQ. 2, 4. So you're going to do, so for PQ, it would be 2 squared plus 4 squared equals C squared. This is going to be 4 and 16, which is what? 20 is equal to C squared. C is equal to the square root of 20. If you want to simplify, you can, but if we're really just kind of, what we want to do is just kind of compare what the lengths of all 4 sides are. And if they come out to be square root 20, then they're obviously all going to be congruent to each other. Just to kind of practice, if we do want to simplify our radicals, you're going to make your factor tree, break it down into 5 and 4. This becomes 2 and 2. So radical 20 is the equivalent to 2 radical 5, if you wanted to write it that way instead. I'm going to go ahead and take a second to find, or just confirm that all of those other sides are also going to have a length of 2 radical 5 or radical 20. If so, then this would be a rhombus. Alright, so as you can see, all 4 of these right triangles here are going to have dimensions of 2 and 4. So when we plug those into the Pythagorean theorem to figure out what the length of the hypotenuse is, they all come out to be square root 20. So specifically, this type of quadrilateral is a rhombus because we've proven that it's a parallelogram. Both pairs of opposite sides are parallel, and you've proven that all 4 sides are congruent to each other.